Okay, welcome to today's lesson on Chapter 6, Networks of the IT Essentials 5.0. So today we're going to look at the different components of networks, and we will cover the physical aspects and the software. So let's look at some of our objectives for today. So we have 11 objectives that we're going to look at. We're only going to concentrate on the first 8 or so. I'm not going to cover the troubleshooting or the maintenance part, but we'll look at the principles of networking. We'll just talk about the different types of networks. We'll talk about basic networking concepts and technologies. We'll actually describe the physical components of networks, the LAN topologies, identify the Ethernet standards. We'll talk about the OSI and TCP IP data models, or the layers. And we're not going to really get into how to configure a NIC. I'll let you guys do that in the reading. And we won't really look at the other parts either. So, all right, let's get into it. So, networks. So our networks are systems that are formed by links, and so when we normally think of it, we think of people, and we have our mail delivery system, our telephone system. Telephone system is one of the older ones, our public transportation system, and then we have our corporate computer networks, and then the internet, and the internet being the largest type of a network that we'll focus on. And one of the reasons why we network our computers is so that we can share data and our resources. So when we hook two computers together, that's the simplest type of network that we can have. So normally when we think of networks, we have a collection of hosts connected by networking devices such as computers, printers, scanners, smartphones, and file and print sharers. And one of the big reasons is that we can share resources across the network. Now our networks, when we used to think of them, were within a certain room or a certain building or floor, but today our networks can cover many types of areas. Also, we have to have a physical connection of our network, and there are three main ones. There's copper cabling, fiber-optic cabling, and the wireless network, which is something that we're really starting to use today. Here are some of the main benefits, and I know that we'll see these a few times. So when we have a network, we have fewer peripherals, so we can share printers and scanners. We can increase our communications capabilities, so we can email each other, we can send text messages, we can share files easier. We can also avoid duplication or corruption because we can back up our data to a main server, or we can have it backed up so in case we lose it. Also, if we have a centrally administered network, we can have protection for malware and other things like that. Low-cost licensing. So when we have a network, you can buy special licenses that allow you to install programs on multiple computers, but when that number is used that you've purchased, it will not allow any others to open up at that time. So instead of having to buy 100 licenses for your computers, maybe you only buy 50 of Word, and that way probably your staff are not going to all be using all 100 at one time, so it's a way to save money. So we have three main types. Well, these are three initial types that we can talk about. We have the LAN, which is our local area network, and it's usually a local group connected within one particular area. We have our WLAN, which is our wireless local area network, and it functions a lot like our LAN. And then we have our PAN, which is our personal area network. This is something new they really talk about in the Cisco IT Essentials. And it's, our networks that we're usually using Bluetooth for. So for our keyboards, printers, smartphones, tablets. We have this local network that we're creating just personally for ourselves. Then we have a MAN, which is our metropolitan area network. And this is a network that could span across a large campus or a city, and it can consist of various buildings, and they could be connected wirelessly or with fiber optic backbones. Then we have a wide area network, and this is a connection of smaller networks such as LANs. They could be a connection of smaller wireless networks also, and the most common one we think of is the internet. And we have peer-to-peer networks, and this is when we connect devices directly to each other. Sometimes we can do peer-to-peer networks via the internet, and a lot of times people will do this when they want to download movies and music and share their movies and music. One of the typical ones that this is used with is something called a BitTorrent, and you want to be very careful if you use this. When you do a peer-to-peer network, you're allowing someone direct access to your computer, so I'll always caution people about that. Then we have a client-server network, and in this model you have a server and your other computers request information from that server, and it's sent off to them as the client. Another thing we need to talk about with our networks is our bandwidth and our latency. So the bandwidth is the amount of data that can be transmitted within a fixed period, and it's always measured in bits per second. So we can have BPS or KBS, which is kilobytes per second, MBPS, megabytes per second, megabits per second. Excuse me, don't confuse the bits with the bytes. I think I just did it twice. And then the GPPS, which is the gigabits per second. We measure bandwidth in gigabits per second. If someone tries to sell you something that's gigabytes, 4 gigabytes or 25 gigabytes or 50 gigabytes, that's pretty big, and I don't think anyone is offering that type of service yet. Typically Verizon offers a 50 megabit type of bandwidth program. And latency is the amount of time it takes for our data to travel from the source to the destination. And we have 3 types of data transmission. We have simplex, half duplex, and full duplex. Remember, simplex is unidirectional. It can only go in one way transmission. Half duplex, it goes in both ways, but only one at a time. And full duplex, they're going back and forth at the same time. There's a channel for each one. Something else we need to talk about for our networks is IP addressing. And so you'll see here they give us the 32-bit binary number, so that 101111, etc. And then usually it's expressed to us in a dot decimal format. And there we have that 190.100.5.54. Typically on our local networks we will have something starting with a 192.168.1.5, and every computer on a network must have a unique IP address. Otherwise there would be conflicts and we would have issues with our sharing of information and transfer of data. Another thing you need to understand is IP classes. And so we have class A through E there. Class A is for large networks, and they're usually implemented by large companies and some countries. I think countries could do that to control what kind of information their citizens are able to have access to. Class B is medium-sized networks, usually implemented by universities. Class C is small networks, usually implemented by an ISP for customer subscriptions. And then we have Class D for special use for multicasting, and Class E is used for experimental testing. And then we also have some subnet masks that we see here in the Class A, B, and C. You'll see that there's the unique numbers reserved for those 3 classes. And then our subnet mask, which I just mentioned earlier, and the subnet mask can tell us what kind of class it is. So we'll see in the first one there, 255.0.0.0 is class A, and then the 25.25.0.0 is class B, and then the 255.255.255.0 is class C. And each one of those sections is an octet. So we have actually 4 octets there in that. So we also have our IPv6, which is our 128 bits or a 32-bit hexadecimal value. And you'll see that down there. And it's a global prefix, so a site prefix. And it has a subnet ID in the 4th block, and the interface ID is included in the last block. You want to make sure you read this and you understand this piece. Again, you always want to be taking a look at the materials on the website and reading those and reading all the pieces that go with it. Make sure you look at all the images and all the flash little presentations that are embedded in the reading. So then we have something else that's really important within our networks, and that's our DHCP, or our Dynamic Host Configuration Protocol. We're going to often refer to that as the DHCP server. Usually your router will have that in there. And it's going to assign IP address, the subnet mask, the default gateway, and the domain name system. So and the address for the domain name, so that when we go looking for web pages and so we can connect to the internet, we need to have an address that we can go out to look for those. It's best when you're setting up your network to always configure this so it's automatic. Sometimes we will do a printer or a scanner in our network, or a computer that's acting as a server or a print server as a static IP address, and we will manually enter that. So we have static and dynamic. Static means it's set to one IP all the time. Dynamic means it will change. So a changing IP address for a particular device on the network could cause issues for people finding it or computers finding it. So then we have our Internet Control Message Protocol, or ICMP, and this is used on a network to send and control error message to the computers and servers. And the big thing here is the ping. Your computers will go out and ping a number so it can find other computers on the network. And when it does this, it requests a ping or sent to destination computer to determine the reliability and reachability of a destination computer. Usually it will ping and it will find the best route to get to the computer that it wants to go to. So we have our internet protocols, and a protocol is a set of rules, and internet protocols govern communication within and between computers on a network. So this is very important. And many of these protocols consist of a suite or a group of protocols stacked in layers. So the big one that we think of is the TCP/IP to communicate with each other. And the main function of protocols is to identify errors, compress the data, decide how data is to be sent, address the data, and decide how to announce and send and receive the data. So the information is transmitted most often via 2 protocols, the TCP or the UDP. And then we have ports. So a port is a numerical identifier used to keep track of specific conversations. Every message that has a host contains both a source and destination port. So you want to make sure in your reading that you are very familiar with these ports. HTTP is port 80, FTP are ports 20 and 21. So you'll see Telnet there, POP3, IMAP, SMTP. It tells you what it's used for. So the SMTP is used to send mail. POP3 is used for mail, and so is IMAP. FTP is for transfer of files, and so an HTTPS is the secure way for web pages. So when you're uploading or downloading secure information from a website, you're entering your own personal data, or you're going to your bank and doing banking, you want to make sure it's always a secure web channel, which would be using port 443. And these ports can be changed. Sometimes particular internet providers will block certain ports because hackers have learned how to exploit certain ports. So sometimes you will need to manually go in and change them, especially if you're trying to run your own web server or a mail server from within your own home server or a small office server. So a modem is a device that allows us to connect to our internet service provider. In the old days, we had a modem that was for dial-up. We still have modems that allow us to connect through broadband, and sometimes those modems can connect through a serial or USB port if it's directly. In most cases today, it's going to be connecting to a router, or sometimes, depending on the ISP provider, you will get an all-in-one device that will be your modem and your router and your access point and your HTTP all in one. If you have a clear device, which is a wireless internet service provider, that device is a modem. It's a wireless modem for you to connect to the network. Here are some physical components of our network. You'll see that we have our network devices. We have our computers, our hubs, our switches, our routers, and our wireless access points. So our computers are our actual devices that we're using on our network. Our hubs and our switches and routers allow us to connect our devices via the media. We'll talk about the media in a second. And then we have our wireless access point, which allows wireless devices to gain access to that network. So hubs usually connect our devices to the network, but they don't do any routing. There's no tables in those. Most often they're used to extend the network coverage area. Because remember, we can only have a device using Ethernet about 300 feet away from the router or another device. So our media, we have twisted pair copper cabling. We have fiber optic cabling, which is becoming a new or a important way to connect our networks, and then radio waves for wireless. So here's some more information on the hubs, bridges, and switches, and power over Ethernet. So remember, the thing about the hub is it can extend the range of the signal and regenerate it. Sometimes they're called extenders or concentrators. And then our bridge can connect two LANs together. Remember, a switch has several ports in it, and it uses MAC address tables to figure out how to forward data over the network. So the difference between a bridge and a hub is there is no table in a hub, and we will have collisions sometimes in the hub when there's transferring of data. And then power over Ethernet allows us to use our Ethernet cable to transfer data to a device. So if you do not have a power supply where you would like to put a Wi-Fi access point, you could run the power for that DC power, over the Ethernet wiring, and you would be able then to plug it in at your switch area, maybe in your server room, and you could have that Wi-Fi access point wherever you need it, up in your attic or somewhere like that. So it's a great way to power devices. A lot of times voice over IP telephones are using the PoE, power over internet, to power the telephones. So our routers is a device that allows us to send information over the network, and it's going to use the IP addresses to forward packets to other networks. And a router can be a computer with special network software installed on it, or it can be a device built by a network equipment manufacturer. A lot of times people will buy specific routers to do this, especially if you're in a large network in a company. You're going to want your routers to be separate devices. So remember, the routers contain IP addresses along with the optimal routes to get to other networks. What makes our networking so fast is our routers can determine what the best route is. And then we have our wireless access point. And a lot of times people will think their router is this altogether, but the wireless access point is something separate, the WAP, and it provides network access to devices such as laptops and PDAs. And it uses radio waves to communicate with radios and computers, PDAs, and other wireless access points. There's usually a limited range of coverage for this. Now we have multiple purpose devices, and usually we think of a router being an access point, a DHCP server, our modem, so an all-in-one device. And it's easy to configure and set up. Usually small networks will have this. And they give us an example of one, the Latency E2500. So you might want to remember that. It could end up being on the test, but it's a multi-purpose device. We also have network attached storage. Sometimes you have a special device and it can connect via Ethernet and be able to supply storage to multiple devices. So that NAS device connects to the network, allowing users on the network to access and share files, stream media, and back up data to the central location. So it's a central storage device via Ethernet for backing up and sharing resources. Some other network devices we have: voice over IP phones, hardware and firewalls. So we can have a separate firewall, or we can have a firewall built into our router or all-in-one device, and usually that's what we will have. We have internet appliances which allow, such as web TV, game consoles, to go onto the internet, but they're special network devices too. It's important to ensure that you purchase authentic devices. You don't want to buy something that's a third-party counterfeit. It might not work properly on your network. So make sure that you are buying your computer equipment from reliable resources. So now we're going to talk about cabling, and the first type we'll talk about is coaxial cable. And it is a copper cord network cable surrounded by a heavy shielding. And you'll see in that example there's a copper wire with some plastic and aluminum, and then looks like some brass cable shielding around it, and then the rubber on the outside. We have different thicknesses. We have 10 base 5, 10 base 2, RG59, and RG6 are some of the main cables there. And depending on the cable, they could cover a different distance. Usually it's about 10 megabits per second that it can travel. It has a longer maximum length. For the 10 base 5, it's 500 meters. Remember that small m is a meter. And then the 10 base 2 is 185 meters. So RG59 is most commonly used for cable television in the United States, and RG6 is a higher quality cable with more bandwidth and less issues with interference. Remember, things like fluorescent lights and radio waves can cause interference with our cables. That's why it's usually good for companies to spend the extra money for shielded cables, because it will help with some of the interference. Because the coaxial cable can go a greater distance, sometimes you might run in your network between floors from different LANs some coaxial cable to extend the network. Then we have our twisted pair cabling, better known as the Ethernet Cat5 cabling is the standard that most of us think of. And so a pair of twisted wires forms a circuit that transmits the data. The twisted wire provides protection against crosstalk, so it's really important that that wire in there is twisted. It causes a cancellation effect. The pairs of copper wires are encased in a color-coded plastic insulation and twisted together. So usually there's green, green-white, orange, orange-white, brown or red-white type, and then blue, blue-white. So, and it's usually a polyvinyl chloride that coats it. And so the different types are Cat 3, Cat 5, Cat E, Cat 6, and Cat 7. And then we have the shielded twisted pair, or the STP, which is usually more expensive. And if you have lots of electrical wiring or fluorescent lights or problems with radio waves or microwave waves, then you might want to use this STP cabling. I believe the Cat 5e and the Cat 6 are required for PoE. If you're going to do power over Ethernet, you want to make sure you have the proper cable for that. And the Cat 7 is a newer cable now, and it has a higher bandwidth capability. And then we have fiber optic cable, and this is a glass or plastic strand cable that transmits light. It is a more reliable. It's not affected by radio frequency or electromagnetic interference. The signals are clear and they go further. It's usually more expensive than copper cabling, and the connectors are a little more costly and harder to assemble. And we have different types of fiber optic cable. We have multi-node and single mode. The installation is a little harder to do because you have to use solvents and special cutters to cut the glass or plastic cable in. So now we're going to talk about our different types of LAN. We have a physical topology or a logical topology. So there are two main types. The physical topology is the real layout, where they're physically at, and then the logical, it determines where they are in relation to the host and how they communicate with each other. So we have some types of logical topologies. We have the broadcast topology and the token passing. So in a broadcast, a host broadcasts a message to all the hosts on the same network or segment. There's no order in the host, and so this is an Ethernet-based topology. And then the token passing controls network access by passing a token sequentially to each host. When a host receives a token, it can send data on the network. If there's no data to send, it just passes it to the next host. So each device on the network would be considered a host. So then we have some other physical topologies. We have the bus and the ring. And the bus connects, they're connected by a common cable. On the end there's a terminal, and so the information transmits data one frame at a time, and usually only one computer can transmit there. And then we have rings, a special frame. The token travels around the ring, stopping at each host to transfer data. So there are two main types, single ring and dual ring. So we have some other types. We have star, where there's a hub or a switch and everybody's connected to that hub or switch. In the hierarchical or extended star topology, there's it's a star network, but there could be multiple stars within the network. And then we have a mesh topology, which is connecting multiple together, but they have multiple connections to different stars or different devices on the network. And the one that we think of most as the internet is an example of mesh topology. And then a hybrid is a topology that's a combination of two or more basic networks, such as star, bus, or star, ring topology. The advantages of a hybrid topologies that can implement it for a number of different network environments. So depending on what your needs are, you might have a little bit of each network type of environment. So here are a list of standard organizations within the electronics world, computer world. The one to focus in on is the IEEE, which is the Institute of Electrical and Electronic Engineers. You'll notice a lot of our types of cables that we use are an IEE something, like the FireWire is the IEE 1394, etc., like that. And then also we have the IEE for our Ethernet and our wireless. So they set standards and people follow that. So there are some Ethernet standards. Ethernet is one of the major components of our networks. So Ethernet protocols describe the rules that control how communication occurs on a network. And the IEEE 802.3 is the standard that specifies how the carrier sends multiple access with collision detection access control method. So this is what you want to know, that Ethernet is the 802.3. So in CSMA or CD, all the end stations listen to the network wire for clearance to send data. When the end station detects that no other host is transmitting, the end station will attempt to send data. Unfortunately, collisions might occur in this process. So then we have 10 base T. So this is able to transmit 10 megabits per second. It's older type. Most today are 10-100. A lot of companies are moving to the 1000 base. And the next big one is the 10 GB base T. And that you need 6A or 7 cable, and this would allow for a lot of data to transfer. A lot of companies are moving towards the 1000, especially with all the video and internet-based programs that we're using today. The more data that we're transmitting, the larger amount of capacity or tunnel we need to get that through. So you would need the right kind of cabling. So you could go out and you could buy a NIC card that would be 1000 base, but if you didn't have the correct cables, you would not be able to use that properly. Some wireless Ethernet standards. So we see the 802.11, and this goes, you'll see that we have 802.11 is the original specification, then we have A, B, G, and N. Depending on the level, it will have different speeds, frequencies, and a greater capacity for distance. So here are the standards. What you want to take away from this chart is that the 802.11a is not compatible with B, G, or N because it's on a different frequency. It's on the 5 gigahertz bandwidth. Also, it can sometimes interfere with wireless handset devices for telephones that were used in the old landline types. But all the rest are running on the 2.4 gigahertz, and depending on the level is how far it can transmit the data. So N is the longest at 164 feet or 50 meters. It also mentions Bluetooth here, and Bluetooth is usually considered a personal network device at short distances, anywhere from 30 feet to about 90 feet, depending on the Bluetooth frequency. So now we're going to talk about our TCP and our reference model. So the TCP has 4 layers here, and you'll see we have the application, transport, internet, and network access. So you really want to unlearn this, so make sure you read this in your materials. The other one that we have is the OSI model, which is going to have 7 layers. Again, it's a protocol stack layers, and this is how we're going to transmit our data via our networks. And so in the OS model, it tells us what we're doing with layer 1 to layer 7. There's a little mnemonic how to memorize it. Please do not throw sausage pizza away, with the first letter for each one representing what's happening there. So we have the physical layer, data link, network, transport, session, presentation, and then the application. And then we have how the two layers correlate for the, two different models, I should say, how they correlate. You can see that there. You want to learn this. So in the OS model, there are 7 layers. In the TCP model, there are 4. So 1 and 2 relate to the network access in the TCP. Network and internet are direct transport to transport. And then the application layer is the 5, 6, and 7 layers of the OSI reference model. Some things, our NIC card is our network interface card, which allows our computer or our devices to communicate with other devices on the network, so we must always have a NIC card. Sometimes our NIC cards are PC cards that are in an expansion slot. Sometimes they can be connected via a USB port. When you install a NIC card, you're going to need to update the driver. It's very important that you follow directions of the manufacturer of the NIC card. Sometimes you will need to install the card first, then the software, sometimes the software, and then the card. So I always tell people, make sure you always follow directions. And then you can go in, you can manually configure the NIC card with our protocols, or IP address, or MAC address, or you can do it all automatically via the DHCP server, and that's how we're going to do it in most cases today. The only time that you might not do it this way is if you were setting up a special printer or a server of some type and you wanted to have the device have a static address. You would manually program it. We have some advanced settings there, the duplex and the speed, the wake on the LAN, the quality of service. In most cases, we don't need to go in and do this. This would be a more advanced type of operation that you would need to do. Connecting a router, usually just going to set it, connecting to the router, card's going to automatically know to do this, and it's going to look for that. If you had to set it up, you would need to figure out what your router main address was. Here it gives us 192.168.1.1. That's usually the gateway for most routers, but again, you would know that specifically from the router you were using. If you weren't sure, or if somebody had changed it, you could always ping the router, and one way to do this is to ping a known address you know outside of the router, and you can see the trace route. So you'd ping it, do a trace route, and you could then see where it went through, and you could tell what the gateway was. So here's some basic router setup. We'll go in, and usually you want to change the defaults for the router name, the network device access permissions, and the basic QoSs. So you just don't want to set your router up and never change anything, especially your administrative passwords or your Wi-Fi logon passwords. You want to always make sure you set up encryption for those. Here are some basic things for our basic wireless settings. So what type of network mode is it using? So remember, B, G, and N are compatible with each other. If your devices are all one type on your wireless, or if your NICs are all the same mode, then maybe you would want to change it so it wasn't automatically. You could select N if you had all N's. Then you have your service set identifier, or your SID. It's always recommended that you change this. Depending on your security, you might not broadcast it. Then you have channels. This is usually automatic. If you have a lot of access points, or you have neighbors that are close to you, you might want to change your channel. And you also want to make sure you always set up the security mode for your wireless access point. The best one here would be the Wi-Fi protected access to WPA2. You never want to leave your wireless access point open and not have some type of encryption. Like I said, the WPA2 is the best to date. And also, you just don't want to go on to any open wireless access point either. People, for some reason, think it's a big gift when they get free Wi-Fi, but you always want to know whose Wi-Fi you're logging on to and who else is logged on to it. You could have a hacker who set up a Wi-Fi network for you to log on to, because when you log on to that network, you might as well be connected directly peer-to-peer with that other person's computer. So always know what the network is that you're connecting to. You can connect your connectivity using a GUI interface. Some things that you can do, you can also do it via command line interface, and you can do ipconfig, ping, net commands, tracert, or nslookup. You can always do a Google of all of these to figure out how to do them. They're a great thing to do. Sometimes you'll need to set up your domain or your work group if you have a network within your LAN that you're going to be sharing information from. You want to have the same name for all of the computers on the same work group. We have Windows Home Group in Windows 7. You can read this. I'm not going to really talk about it. We also have sharing resources in Windows Vista. Again, take a look at this. Make sure you learn the paths there. Some sharing resources in Windows XP. You have the Network Setup Wizard, and then there's the path how to get there. Again, you want to make sure that you take a look at this, read it, and understand it. Network shares and drive mapping. This is some information here, things that you might need to do. In most cases, you don't need to change all this. But again, go ahead and read this and you make sure you know what the different terms are there. Then we have our virtual private network, our VPN. And it's a private network that connects remote sites or users together over a public network like the internet. So a lot of companies today won't run direct lines between their buildings, or will allow their employees to use their own home internet to connect to the work, and when they log in they use the virtual private network protocols, and it's just like they're on the same network. Sometimes things will get locked out and they can't do certain things. Usually you have a VPN client and it's going to encrypt the data, and then there's a VPN gateway to establish and manage the connection. Key word there is VPN tunnel. Here's a diagram of it. So you'll see that it's using the internet there. Point to it right here. I point it with my finger. You can't see that. You'll see that here's the company headquarters. Here's the person networking in. Sometimes it can connect a couple buildings, or sometimes it's just logging in and there's a special password to log in. The next few slides talk about different types of connections. There's the DSL, which is a digital subscriber line. So slower rates. It was better than dial-up, but today with broadband, between Fios and broadband cable or wireless broadband, DSL is not used a lot. Here are some different types of DSL. You want to make sure you become familiar with these and the rates for each. And there were some line-of-sight wireless internet services. Again, it means you have to be in direct sight, a path with the tower and the customer. Can be a little bit faster. So it's an always-on service using radio signals. You want to make sure you know that. You need a clear path. If anything's in between, then it won't work correctly. So extreme weather conditions, trees, and tall buildings can affect how this line-of-sight wireless internet service works. Then we have a WiMAX, Worldwide Interoperable for Microwave Access. It's 4G broadband, high-speed mobile internet, and the protocol is there. The IEEE 802.16e has download speeds of up to 70 bits per second, and a distance is up to 30 miles, so it's pretty big. It uses low wavelength transmission between 2 gigahertz to 11. A fixed WiMAX A point to A point to point multiple service with speeds up to 72 megabits per second with a range of 30 miles. And there's the mobile WiMAX for mobile service like Wi-Fi, but the higher speeds and longer with higher speeds in transmission. So this will be our 4G cellular service with the Wi-Fi with it. And then we have some other types. We have cellular, which was the 3G and the 4G. Cable, which uses coaxial cable line. Satellite, which uses a satellite dish for two-way communication. Usually that would be used in rural areas. And then the fiber broadband, which is faster, more reliable, no interference from weather. It could be DSL also, and Verizon is the big provider of this. If you're helping a customer select an ISP, you want to consider four main things: the cost, the speed, the reliability, and the availability. And there are different types. We've talked about these already: POTS, the ISDN, DSL, cable, satellite, and cellular. So the next few slides, we talk about preventive maintenance. So on preventive maintenance with networks, you're usually considering swapping out NIC cards and routers and wireless access points because they're used on a regular basis. It's always transmitting data back and forth between our NIC cards and our routers and our other devices that sometimes large companies will do routine updates, meaning that they'll swap out different devices to make sure the network is always running so they don't have downtime. You want to make sure cables and devices are all labeled properly, so when you do need to switch components, it's easier to do. And we want to make sure our routers and different power devices are going to have a UPS to ensure that they have power when there's a power outage, especially if your telephone system is running over a network. And then the troubleshooting process, it applies the same for this as for other parts of the course. So we have our 6 steps: identify the problem, establish a theory of probable causes, test the theory to determine the cause, establish a plan of action to resolve the problem, implement the solution, verify the full system functionality, and then implement preventive maintenance, document your findings, actions, and outcomes. Now, just like with some of the other things when you're working with printers and operating system, there are some typical things that can cause problems. Maybe the NIC card wasn't installed properly. Was the IP address assigned? Is the cable unplugged? Sometimes restarting the computer can create that network connection again. So there's some general things that you'll learn to do. You can always use, your friend Google and Google your issue. If you don't have if you have green lights everywhere, you're not sure why it's not working right, you can check that. One thing to always do is see if other computers on the network have network connectivity. Maybe the router's down. Maybe someone turned the router off. Is the network out? Sometimes the worldwide network goes down on certain areas. So they're just things that you will learn to do when you're troubleshooting so you don't spend a lot of time. So long chapter, networks are really important today. We use this networking for everything that we do, especially with all our smartphones, connecting to our printers, and we're wireless. We want everything to be convenient. So make sure you understand this chapter really well. So that's it for today, and make sure you do read the material, and next time we'll look at chapter 7, which is laptops. All right, have a great day. Thanks.